MacMaths, let's do some maths today. Okay guys, so here I am on location today in Mr. Darren's room. If you recognise the board, about time there was a decent mathematician in this room. So I'm back in school, hopefully see you all on a Zoom tomorrow. But today there's lesson 2 of the partial fraction series, part of this Algebraic methods chapter 1 in the A2 core mathematics Pearson book. We're looking at repeated factors. Okay, so a little quirk on what we looked at yesterday or in the last lesson. So why are these ones different? Okay, so we're just going to look at the specifics of repeated factors. I'll do the first two with you. So from the exercise, this is number 1 and number 2. This is exercise 1A, and then 8B is the very last one of the exercise. So I'm not going to do these two. I'm just going to set them up for you and let you have a go yourself. But you'll get it from doing these first two here, from number 1 and number 2. Okay. So these are quite clearly algebraic fractions. We're going to write them as partial fractions over their factors, like we were doing last time in lesson 1. But what's different about these is that they've got this repeated root. So you've not just got x, you've got an x squared, or you've got an x plus 1 all squared. The reason that I've put 1 and 2 on and then 4 and 8b on there is because you can see here that these ones have already been factorised for you, and you can see the repeated root, okay, on the repeated factor, sorry. On these ones here, you can't see it, so there's a little bit of work to do with those. All right, so let's start and do this one. Okay, so if we were doing this one, we look at this, and this is how you do it. So we're going to go 3, and I'm going to do it all, 3x squared plus x plus 1 all over x squared times x plus 1. And I'm just checking that it goes on my screen there. Yeah, just about squeezes, and I've got to be careful not to get too close to this side. Okay, and that can be written as, now, this is how you deal with these, your factors. So we've got a factor, first of all, of x squared. So you put the repeated factor in its entirety, as in the repeated bit. So x squared is one of the factors. But of course, a factor is also x. And the factor here is x plus 1. Okay, so the repeated roots, you get all 3 factors in. So the factor there, x squared and x. So on this one, when we do this one, it's going to be x plus 1 and x plus 1 squared are going to be 2 separate factors here. Okay, so you must remember to do that. If you don't do that, okay, then you won't end up with the right set of partial fractions. It won't work. Okay, and this green is now. Okay, let's have a. Yeah, no, I don't think so. I might buy Mr. Darren some decent pens as a treat. So let's do this one then. I'll go back to black. Here, x squared. How do we change this into all of that? We times the top and bottom by x plus 1. So we times the top by x plus 1. Okay, and now that's the same. This one, we'd have to times it by another x and an x plus 1 to give us x squared times x plus 1, which is what we've got here. So we have to times the top by x and x plus 1. And this one, we have to times it by an x squared, don't we? So we have to times the top by x squared. That means now that all of these have the same denominator, don't they? Yeah, they've all got the same denominator now, which means that we can write all of this top over the same one denominator. So we can write a times x plus 1 plus b times x plus 1 plus c x squared. Okay, and all of that is going to be equal to this top bit here, because, you know, if we wrote all of that out as 1, we can replace all of that now, can't we? So missing out a step here. And okay, so because all those denominators were the same, we can write it there, can't we? Like that. Okay, so now we're saying that this top must be equal to this here. So this is our 3x squared plus x plus 1 must be equal to that. Okay, and now we're in business now, so I'll do it alternate colours. Why? Just because it looks pretty. With this one here now, okay, we're going to pick a substitution. Remember, that's what we're going to do. I'm going to go with x is 0 straight away. That's nice and easy. X is 0. When x is 0, all of that is 0, so we've just got 1 on the end. And when x is 0 there, we get 1a, don't we? 0 add 1 is 1, so 1a. There's a 0 in there, so all that will be 0, and 0 squared is 0, so times c is 0. So a is 1, got it straight away. If I go with x is minus 1, okay, and put that into there, minus 1 squared is 1, so I've got now 3 minus 1 add 1 is equivalent to, that goes, is equal to c, so that's nice. So 3 is equivalent to c. Okay, and then for B, there's nothing that will cancel out just one of these two. So this is where you just get a little bit inventive. You don't have to get that inventive. I'm just going to go x is 1, okay, for this now to finish off. So I've got a and c, but if I go x is 1, you can see now I've got 3 plus 1 plus 1. So on this side I'm going to end up with 5. And putting 1 in here, okay, for x is 1. 1 add 1 is 2. 2a, but we already know that a is 2. But I'm going to put that in for now. So I've got a times 2 plus, now it's b that we don't know. I'm putting this in as 1. So 1 add 1 is 2. 2 times 1 is still 2. And c here, and we've got x is 1, so it's just c. Okay, so I've got that now, haven't I? But I already know that a is 1, so 1 times 2 is 2. I don't know what b is, so b times 2 is 2b, and c I know is 3. Okay, so 2 add 3 is 5, so 5 is equivalent to 5 add 2b, and when you take 5 off both sides, you can see that b is 0. B is going to be a 0. Now that's nice, now, because it just simplifies what our answer. You sometimes get that, and that's going to simplify our answer now. Your red pen is. There you go, it's better. Preparation is everything. Okay, so now when I put them back into that original one, I've got, I've rubbed it all out, didn't I? I had it originally as a over x squared plus b over x plus c over x plus 1. That's how I had it originally. Okay, and from that now we know that this can be written as a, which is 1, so 1 over x squared, b is 0, so that's all 0, plus c, which is 3 over x plus 1. And despite one of those roots being out, we still had to do it that way. We had to do all of the roots. So 3x squared plus x plus 1 all over x squared times x plus 1 is equal to that in partial fractions. Okay? There we go. Just checking that all fits in to my screen. Yep, there we go, that's good. Alright, and the more you do these, you speed up, really, with them. Let's go down, let's do this one now a little bit quicker now. Okay, so we're saying that we've got minus x squared minus 10x minus 5. You might want to put it on pause and have a go yourself, times x minus 1 is equivalent to, and then all of the roots. So we're going to go a over, and I'm going to go x plus 1 squared, that's the repeated bit, plus b over x plus 1, that's just one unit of it, that's all also in there, and c over x minus 1. Okay, so now I'm going to go that minus x squared minus 10x minus 5 there's got to, so I'm just doing the top row now. Now that, I'd have to multiply it by that top and bottom. So that's going to be a times x minus 1. That one is going to have to be, would have to be times by another x plus 1 to get that, and an x minus 1. So a bit of a mouthful now. And c has got to be times by x plus 1 squared. Okay? Go timesing that by x plus 1 squared, c times top by x plus 1 squared. So that is equal now. So what are we going to go with? Well, the two that we're going to go with to cancel out is x is 1 and x is minus 1. So first of all, I'm going to go where x is minus 1. Okay? When x is minus 1, let's do it there, we're going to get minus 1 squared is 1, so, but I've got a minus in front of it, so I've got minus 1 plus 10 minus 5 is equivalent to, now x is minus 1, minus 1 is minus 2, minus 2a. Minus 1 there makes that 0, so that's all gone, and minus 1 there cancels out all of that. That goes. Okay, so now putting it into this, we've got 10 minus 6. So 4 is equal to minus 2a, so a is equal to minus 2. Okay, now I'm going to go x is equal to 1. When I put x is equal to 1 in here, okay, that cancels that one out. Okay, so, oh, hang on, let's put x is 1 into there, so I get minus 1, 1 squared is 1, minus, so it's still back to minus 1 again, minus 10, minus 5, a lot of negatives there. Putting 1 into here, you do have to be careful with this, don't you? I'm nervous about making a mistake here on camera. 1 take 1 is nothing, so that's all gone. The 1 in here, 1 take 1 is, so that's all gone. And when x is 1 in there, we get 1 add 1 is 2, 2 squared is 4, is 4c. Okay, you can see that all of this is minus 16 is 4c, and divided by 4, c is minus 4. Okay, and so the last one is, it's b that we haven't got, so let's just go x is 0. Okay, so when we go x is 0, that handily gets rid of all of that, so we've just got minus 5 is equivalent to minus a, because 0 minus 1 is minus a. X is 0, so we've got 1, this is all 1, times minus 1. Minus 1 times 1 is minus 1, minus b. And c, we've got x is 0, so 1 squared is 1 plus c. So we've got that. Okay, minus 5 is equivalent to minus a minus b plus c. But we know that a is minus 2. So we've got minus 5. If a is minus 2, minus 2 is plus 2, minus b, and c is minus 4. Okay, so we've got minus 5, 2, take away 4 is minus 2, and then we add 2 to both sides, so we get minus 3 is equal to minus b, so b is equal to 3. Okay, now because b is the only positive one here, we've got a is minus 2, c is minus 4, and b is a positive 3, let's write that one first. So our answer, this, okay, do it in a different colour, I'll do it in black. These are horrible, these pens. Which one did I use that was nice before? Yeah, that one. Okay, so let's do the b first. So we've got, because that's positive, so we've got 3 over x plus 1, and then we can put the other 2 in now. So minus a was 2 over x plus 1 squared and c was minus 4 over x minus 1. There we go. So partial fractions take a little bit of time, don't they? You can see that. And you do have to be careful because there's loads of scope for making a mistake there. All right. Okay. Mr. Darren's got that there. All right. So number 4 and number 8 from the exercise 1E are like this. So I'm not going to do those, but I will just set them up for you. Okay. This one, the bottom bit, you've got the top, which is 5x squared minus 2x minus 1. And of course the bottom, if you factorise that and take out x squared, you get x squared taken out and you get x minus 1, don't you? Okay, so your roots for this would be a over x squared plus b over x plus c over x minus 1. That's how you would do that one. And this very last one here, you can see you've got a cubic function on the bottom. So, I don't know if you can, you might not be able to see that, however, squeeze that in. So the bottom here, let's do the top first so it's not confusing when you're watching this. The bottom is going to take out nx first of all, and you'd get 4x squared minus 4x plus 1. Is that right? Yeah, plus 1. Okay. And then this one here is going to factorise, isn't it? Now that is going to be 2x minus 1 all squared, isn't it? Is it 2x, 4x, minus 2x, minus 2? Yeah, so it's going to be that. So that's your repeated root. So when you do, when you factorise that, you get to that. And then so you're going to do it as a over x plus b over 2x minus 1 plus c over 2x minus 1 squared, the repeated bit. Okay? Alright? Oh, that makes sense. So do those. You should have done the exercise 1D, do 1E with the repeated, this little quirk of repeated factors. I keep saying roots. We know that factors often lead to roots, don't we? That's why I keep saying it. Plus I'm 53. So my brain is going, okay. Got a mortgage still. Okay, all right.